Turbulence can be terrifying.
I've never heard it make a sound like almost like you were landing on something and then a big boom like you'd hit something.
It can be unexpected.
My book started flying and everybody was kind of screaming, yelling. There was a really, really good second there that I was positive that we were going down.
It can feel out of control.
I ended up crying. I turned to my husband saying, not to be dramatic, but I literally felt like we were about to crash.
And sometimes it can be deadly.
Singapore Airlines confirming one person has died. Several others are hurt this morning after a flight from London to Singapore experienced severe turbulence.
This week, we are going off the radar and taking to the skies to better understand turbulence. A researcher will explain the science of why this happens and why it's getting worse in a changing climate.
Turbulence is just one of the hardest problems in all of the sciences to solve.
We'll also hear from a pilot about why you might be overreacting when the plane starts to shake.
Yeah, you're gonna drop and you're gonna get bumped and kind of do this kind of stuff. But planes are built inherently stable, so that's the biggest thing to take away. Even the smaller planes.
So keep those seatbelts fastened as we take a bumpy ride into the science of turbulence. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Hi, everyone. My name is Emily Gracie, and I'm scared of turbulence. I haven't always been, but for some reason, in recent years, the first bump on a flight sends me into a panic. And I know I'm not alone. I also know it's totally safe. I've been told this many times, and even by both of the guests that I have on the show today. But similar to weather fears, sometimes understanding why things are happening can help people overcome those fears. So I wanted to do this episode for a long time. My friend Josie told me, do not do that. Whatever you do, don't do an episode on turbulence. She said I was indulging my own fear and making it worse. But given recent events with the Singapore Airlines flight, I thought this might be a good time to set the record straight on turbulence. Now, if you're scared to fly, I don't recommend doing what I did and searching up turbulence on TikTok. That's a dark hole of terror that you won't come out of unscathed. But I do recommend listening to today's show. Both of my guests are extremely knowledgeable on turbulence, and neither one of them seemed particularly worried about it at all. First, we'll hear from Justin Chambers. He's a meteorologist at Fox 45 in Baltimore. He's also a pilot. Not only that, but he's a flight instructor. And then we'll hear from Dr. John Knox, an atmospheric scientist from University of Georgia. He's been studying turbulence for decades and has some very insightful information about why it occurs, why it can be unpredictable, and the parts of the globe where you're most likely to encounter it. Thanks for tuning in. Be sure to give the show a follow if you enjoy what you hear today. Let's start with my conversation with meteorologist Justin Chambers. Justin, you are the morning meteorologist at Fox 45 in Baltimore, but you have kind of this whole other life. We see it behind you here, but can you tell me about what you also do when you leave the station?
Yeah, well, I'm also a pilot, and I'm also an instructor part-time. So I actually instruct people how to fly and, do cross-country flights or whatever kind of flights we're doing. I have a student that I'm about to go out with today, and we're going to practice some takeoffs and landings around here in Maryland. It's a gorgeous VFR day. I always talk about that on TV, about VFR, visual flight rules. So, but it is summer, or summer-like, because our temps are warm, and that means you get density altitude. That means you get the rising air and turbulence.
Turbulence. That's what we're here to talk about today. Can you tell me what your reaction was when you saw the news from Singapore Airlines this past week?
Yeah, really sad, obviously. I mean, my wife is a flight attendant, so I'm scared every time that she's up there, no matter what, because she's up and moving around and the passengers are not supposed to be up and moving around. That's why it's so important to keep your seatbelts on. She always tells me that. But she has to get up and, do her demonstration and, serve cocktails or whatever it is. And she's there for their safety. But at the same time, she's standing up and, something like that can happen. So when I hear that, I instantly get a little bit worried, thinking about, I hope, she's okay on her flight, because I know it could happen at any time, at really any given minute too.
Yeah. And have you noticed in your flying over the years, have you noticed more turbulence?
I don't know that I'd say more. I've only been flying for about 6 years as a pilot. You definitely feel it more as you get warmer. There have been some real, even in the spring, there have been really, really windy days around here. And I won't even say windy. It wasn't even that windy at the surface, but up there, 4,000, 5,000, 6,000 feet, it is extremely bumpy. And I did notice that this year, that it was more so than it was the last couple of years flying here around the Chesapeake Bay. So I don't know what that kind of correlates to. I mean, I know we're definitely warmer overall, but I know that even in my small planes, we definitely feel it there, and we try to go high to be cool, to cool off and to get smoother air. But sometimes you just can't do that, and sometimes you get bumped around, and so.
Yeah, is it ever scary for a pilot to encounter turbulence?
No, 100%. Yeah, absolutely. I mean, I still, I fly usually a Cessna 172 or a Cirrus SR-20. And, they're very stable airplanes, but you get bumped around and you're in the little tiny cockpit and you're the one who's flying. So, you don't have really any control over what happens there. All you can do is pull the power back a little bit and try to, ease the fact that you're going through some turbulence. But the only thing you can do is just kind of slow down and just kind of take it easy. But yeah, it definitely takes your breath away. And sometimes, you do get, your headphone gets popped up to the top of the roof and you're like, okay, that was it's quite bumping. I do not like it. I do not like it. No one likes it.
No one likes it, but it's like a straight up panic attack for some people, and especially on commercial aircraft. So I'm curious, as a pilot, when you're flying commercial, do you get scared when there's turbulence?
I don't know that when I'm flying commercial, I don't get as scared because I know that those planes can handle a little bit more. And if you get kicked around, especially if you're, pretty high up, yeah, you're gonna drop and you're gonna get bumped and kind of do this kind of stuff. But the planes are built inherently stable, so that's the biggest thing to take away. Even the smaller planes, that they're built to be able to handle that. Now, I can't take my little Cessna into. I mean, I'm never going to fly into a thunderstorm, and even commercial airlines don't fly in thunderstorms. They fly above them or around them. So that's why there's delays. And those are good delays to have because I know it's annoying and, it's travel weekend, whatever. I want to get home. I want to get back home, get to where I'm going. But if it's delayed because they're going around a thunderstorm, that's a good thing. So they don't need to mess with that. So, the main issues we see, like we saw from that flight and like we've seen in other reports, is that people get injured when they're in the fuselage and they're walking around. Even people who are not walking around, when they're strapped in, sometimes they can still have injuries with that. But more than likely, that plane is going to be just fine. It just has to get through that bumpy stuff because you get stuff that's rising from the earth and it's kicking all the stuff around, and you got stuff up there called clear air turbulence, and they're trying to be able to detect that better and everything. So, the industry and aviation as a whole is definitely taking good steps forward to be able to try to allay people's fears and make it so that, people won't be scared to fly.
Now here's my talk with Dr. John Knox from UGA. Dr. John Knox from UGA, thanks so much for coming on the show today. There's a lot of buzz right now about turbulence. So I really want to get to the source of this and talk to you, an expert on, how air is moving in our atmosphere and what exactly is going on here. Can you give me a little background on yourself, like where you are, what your expertise is?
So I'm a professor at the University of Georgia. I'm the undergraduate coordinator and associate director for the Atmospheric Sciences program. I've been doing research on aviation turbulence since the mid-1990s.
What have you seen since the mid-1990s? Because there's been some changes, right?
There have been quite a few changes in both the amount of turbulence, but also the way we approach the problem. The way in which turbulence was forecasted in the early days was kind of a seat of the pants thing. A pilot experienced turbulence and the aviation meteorologist looked at the weather situation and tried to put two and two together. So what that led to were a bunch of different diagnostics, as we call them, for turbulence, not all of which necessarily worked at the same place at the same time. And so what we've been doing more recently, Bob Sharman at EDCAR is the person that's really pioneered this approach, is to take these different indices for turbulence and put them together in a statistically optimal way so that you get one number rather than a whole bunch of different numbers for explaining where turbulence might the more likely or less likely. Meanwhile, in the real world, what's been happening is turbulence has been occurring more often. There's been work done by my colleague Paul Williams at the University of Reading, who he's shown that convincingly that turbulence has been going up quite a bit, perhaps as much as 50% in the mid-latitudes. That is where a lot of the airplanes fly, say from across the Atlantic, from North America to Europe. Severe turbulence has increased about 50% since the late 1970s to now.
Can you back up and kind of break down turbulence for me and let me know? Because I know there's different types. Can you tell me the different types and how they occur?
There's lots of different kinds of turbulence that occur on an airplane, and turbulence is just in-flight bumpiness. It's as simple as that. It's defined by the experience of the pilot or the passengers. What causes that? It depends. On a sunny day, you can have air thermals, warm air moving up and down in the atmosphere, and that will make your plane move up and down. The more severe kinds of turbulence are often associated with wind blowing over mountains, leading to waves that propagate upward in the atmosphere, and then just like ocean waves can break, and just like on the ocean or at the seashore, you see the foam on the wave, the breaking wave. Well, that's kind of what you're flying through if you fly through a breaking wave, except you can't see the foam. You just fly through it, and it's extremely bumpy and chaotic. So that too causes turbulence. There are other kinds of waves that also can lead to planes getting bumped that aren't associated with mountains. And if there's no clouds nearby, we call that clear air turbulence. But in the end, a lot of it comes down to fairly small scale, kind of plane scaled turbulence that is related either to breaking waves or to what we call instabilities in the atmosphere. And so in the end, it's something that we can't directly simulate in today's computer models. So we forecast it by larger scale properties of the atmosphere that we can simulate accurately. It's a little bit like the way we do tornado watches. We don't directly simulate tornadoes in computer models. We simulate the larger scale environment that is conducive to tornadoes.
Okay, interesting. I like that analysis there. So tornado forecasting's gotten a lot better.
Mm-hmm.
Is there an improvement in turbulence forecasting? Is there a future where we can predict this?
That's a great question. With regard to tornadoes, the size of tornadoes, as we know, if we're into tornadoes, is like a mile wide, and it lasts for up to an hour, we'll say, in the more severe cases. The problem with turbulence is that it's a lot smaller than that, and it may exist for just a few minutes. And as you get to the smaller things that last a shorter period of time, it's harder and harder and harder to forecast. And so I think we'll probably be making direct tornado forecasts before we'll be making direct turbulence forecasts. Also, turbulence is just one of the hardest problems in all of the sciences to solve. In the equations that describe the atmosphere, I teach my students at the University of Georgia, you can't actually get a perfectly closed solution. That is something that you could write with pencil and paper to get at turbulence. You have to make estimations, and so that introduces problems and errors into the calculation. So no, I don't know that we're going to be making direct turbulence forecasts anytime soon. So we still have to forecast the larger scale environment and extrapolate that downward, downscale, as we say, to the level and size of an airplane.
But it has gotten better, right?
Yes. The algorithms that are used today to forecast turbulence are largely something called graphical turbulence guidance, created by Paul Sharman and his associates at NCAR. And that takes a bunch of different indices for turbulence that have been shown to be good over the years and combines them statistically. And so that's really how things are being done these days. It has the advantage of not relying on any one index, because there is no one index that forecasts turbulence perfectly or even close to perfectly.
Okay, so in the way that we forecast weather and we forecast tornadoes and hurricanes, there's a lot of initial data that is going into computer models. Is there a way in the future to get more initial data, or is the only way to get this data to actually fly an airplane through it?
We're getting much more data from airplanes than we ever did before. Across the world, many of the wide-body jets that fly now provide accelerometer information, which is an objective measure of turbulence. In the old days and still today, turbulence is rated on a scale that goes up to severe and extreme, and that is a subjective measure if it's reported by a pilot. And so one pilot's extreme might be another pilot's moderate turbulence. And so that was not useful for scientific research. It's very useful in real time to know if a pilot is flying through what they think is moderate or severe turbulence. But the accelerometer data these days allows you to get independent information on it. And so that information is very useful. And I think over time, more and more aircraft information will be ingested into forecast models to be able to make more and better real-time forecasts of weather period, but also of turbulence, at least in the larger scale environment.
Okay, so let's talk about what's going on in different parts of the world and kind of break it down as far as this specific flight that just recently happened with Singapore Airlines and where it was going and what it encountered. Can you kind of let me know, like, what parts of the world are going to be more turbulent?
Most of the research that's been done so far on turbulence in the future has been done with relation to the mid-latitudes. And so, say, North America to Europe, or also Asia and so forth. There's a reason for that. We have a better handle on what causes turbulence in the mid-latitudes than we do in other parts of the world, such as the equatorial tropical regions. And that's because, honestly, we have a better handle on weather, period, in the mid-latitudes than in the equatorial regions. And so the prediction is, and it's already been verified in terms of evidence, that there is more turbulence because the upper tropical troposphere, so the region of the atmosphere that is where cruising airplanes would fly, but more toward the equator, that area is actually getting warmer over time. And meanwhile, the poles at those altitudes are staying relatively cold. So there's an increased temperature gradient as you go from the equator toward the pole. The stronger the equator to pole temperature gradient is, the stronger the west to east winds will blow in either hemisphere. And so if the jet stream is blowing faster, this means that the wind shear, the vertical wind shear, will be greater just below the jet and just above the jet, because wind shear is a change of wind over distance. And so vertical wind shear is just simply the change of the wind as you go upward into the core of a jet stream, and then as you go above it, out of the core. This leads to turbulence because ultimately you get a combination of things, one of which could be gravity waves, but most specifically, you reduce a number called the Richardson number, a very famous number in turbulence. You reduce that number to the point where an instability kicks in. It's called a Kelvin-Helmholtz instability, and it looks like little second graders waves.
We've seen those clouds, yeah.
If you fly through that, either there's not much cloudiness there or maybe no clouds at all, that's when you will get pretty severe bumping. And more planes will fly through more of that, ergo more clear air turbulence.
Let's talk about being on the plane. I myself have an extreme fear of turbulence, and and it doesn't matter how many times somebody says this is not dangerous, especially when you see videos like what we saw this past week. Can you tell me about what this does to a plane, especially once you get into this like moderate or extreme situation?
Really, there's not that much to be worried about. I know that doesn't help, but it's true. Very, very rarely do you have an airplane affected by turbulence to the extent that the airworthiness is threatened. In other words, turbulence isn't going to knock a plane out of the sky. That's a very, very rare occurrence. more likely what can happen is that in the severe to extreme range, you may have a risk of a part of an airplane coming off. In an extreme mountain wave case, there was a situation where an engine came off. Now, of course, engines are designed to do that. That's okay. That doesn't crash an airplane. I know it sounds crazy. It sounds crazy, but it's better for.
I don't want an engine falling off my plane.
I know, but you can, if you've got 4 engines and one comes off, the pilots can still handle that. So that's in an extreme case. You shouldn't worry as much about turbulence as you probably do, but it is scary because you're trapped on the airplane. You don't know what to do. What you should do is have your seatbelt fastened at all times. They always say it, and it seems like nobody does it, but you should, because you never know when you'll fly into clear turbulence. It's sneaky because it happens usually at or near cruising altitudes, at high altitudes. And this is when your guard is down because you've probably already had your white knuckle moment when the plane took off, and you're ready for your white knuckle moment when the plane lands. And so your guard is down, but it shouldn't be. Keep your seatbelt fastened. That will keep you from being thrown around if, in the rare case of severe or extreme turbulence, you start to pull G's. And so you fly up or you're slammed down in your chair. Just have the seatbelt fastened. Most of these turbulence events last a very short amount of time because the pilots get the heck out of it as soon as they're in it. So they either climb or descend. Turbulence events, as scary as they are very, very unlikely to do anything terrible to you except scare the crap out of you. And
they definitely do that.
Right. But understand that the number one thing you do is you fasten your seatbelt low and tight across your lap, and that should keep you from serious injury.
Do you know anything about new tools being used to forecast, any new research that's being done right now on turbulence? I've heard, talk of like using AI to, predict it, or using LiDAR to predict it. Do you know of anything new that's happening with research?
LiDAR has often been mentioned as a way to detect, not necessarily predict, but detect turbulence in the atmosphere immediately ahead of an airplane. And so LiDAR is just simply radar using light waves. And because visible light has a very short wavelength, it can pick up on the kinds of clear air turbulence that you can't see with radar, which is a much longer wavelength. And so that's hoped to be a tool that can help give seconds of warning to the pilots, but that may even be enough. I don't know the exact details. I've been hearing about LiDAR as kind of the secret fix-it tool on turbulence for a long time, but we're still running into turbulence. So I think that's something that's promising for the future. As far as forecasting it, which is a little bit different, not detecting it, but forecasting it, AI is an obvious option because AI is great with data, especially for situations where we have a lot of data, but we don't have as much theory as we need to be able to understand what's going on. And so that's this problem right there, because we have a multiplicity of reasons why turbulence can occur, and we don't even know if we know all the ways in which turbulence occurs. We're gathering a lot of data from airplanes on flight routes, and so it seems like a natural to put the two together and to see if AI can put together some pieces of the puzzle that elude us.
So really, clear air turbulence is the most dangerous one.
Well, I'm not sure I'd say that, actually. There are other kinds of turbulence that are more worrisome. That's because the turbulence may happen at low altitudes. For example, you can have turbulence associated with a gust front out of a thunderstorm, or you can have turbulence related to thunderstorms, in thunderstorms, or near thunderstorms. I think all of those can pose greater risks than clear air turbulence. The best thing about clear air turbulence is, by its definition, it's above about 15,000 feet. It often happens at 25, 30, 35,000 feet. That's a lot of altitude to play with. And so that means that pilots have options to get out of it. The scary part is when you're near the ground and you're running into turbulence that can affect the airspeed. It could lead to stalls or things like that. So I think clear air turbulence is at the top of the list for just panicking passengers, because it comes when you least expect it. In the case of the Singapore Airlines incident, it came during breakfast. And so I'm sure that a lot of the crew were injured because they were up serving breakfast. I would put clear air turbulence tops in terms of the panic effect, but not as high as turbulence that you encounter closer to the ground in terms of actual risk.
Yeah, it's interesting because I would say like I panic much more when we're higher up because I'm like, oh, we got farther to fall, Whereas stuff closer to the ground, if I can see the ground, I'm like, all right, we're almost there. I can manage.
But from a pilot's perspective, it's just the opposite. Namely, if you're close to the ground, you have less room to maneuver.
Yeah. Interesting. Is there anything else you want to add about turbulence or the recent story?
The predictions that we've heard about turbulence in the future are mostly based on our understanding of turbulence in the mid-latitudes, such as North America to Europe. It's less well understood what's happening in the tropics or what will happen in the tropics. Most of the turbulence there is probably associated more with thunderstorms. And in fact, that may well be what happened to the Singapore Airlines jet when it flew and then ran into severe turbulence and had to make an emergency landing. That's more commonly what's going to happen in the lower latitudes these days. And in the future, that probably will happen more often, but that's a little harder to predict. But the initial indications are that turbulence across the globe will increase with time, perhaps in the mid-latitudes, mostly because of a stronger jet stream that leads to more instabilities and waves that planes will fly into. And in the tropics, due to more vigorous convection, because another aspect of climate change is that you warm the oceans, and this gives more and more energy to the thunderstorms that form. So no matter where you are on the planet, it does look like aviation turbulence is going to be on the increase, especially the turbulence at high altitudes, which we call clear air turbulence.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes published every Tuesday. If you liked today's episode, please share it with a friend. I'd also love you to rate and review us on Apple Podcasts and Spotify. Let us know what you think of the show, and you can give me ideas for future episodes. Thank you to Justin Chambers and Dr. John Knox for their expertise today. For the National Weather Desk, I'm meteorologist Emily Gracie. Make it a great day.